Hello. So now we will be working on problem 46, which is to let x and y be any two sets and let topology y be a topology for y. If the function goes from x to y is any function, show that topology being the set of A subset x, where there exists a B in topology y such that A is equal to the inverse image function of B is a topology for x. So to prove something is a topology, we have to make sure that that topology follows three rules. And something I'll point out is that topology Y can be any topology, but we know that any topology must contain at least the empty set and the universe. That's why we're trying to prove it here, but we know that topology Y is a topology for Y. And another thing, for topology Y, we usually say open sets G, but for topology Y, we'll be using the letter B as sets. It could be any set. And this topology that we're trying to prove will contain A in place of that B, and where A is equal to the inverse image, and well, from B is in topology Y. So I'm going to erase those, and we're going to move to the next page. I'll leave the A here. So to prove that the empty set is in the topology X, we'll now label it with an X. We want to show that the empty set is a subset of X. Here I'll rewrite topology Y. Remember, we already said it's a topology, and every topology contains at least the empty set and the universe. So the empty set is a subset of X, and there exists a B in topology Y such that the empty set is the inverse image of a B. Remember, for topology X, we'll now start labeling it with the X. It's equal to the inverse image of B, where B exists in topology Y. So for this problem, namely B equaling the empty set right here would give us the empty set, so it will land in the topology X. So then the empty set exists in topology X. And now for the universe, it's a subset of the universe, which exists in topology Y. So there exists a B in topology Y such that X is the inverse image of B. And we actually don't handpick the universe here. We pick for B to be any Y. This image would look like if we chose B, if we chose the empty set, it would move over and land in the empty set. For this one, we choose any B, we just say Y, and it will land on the universe on that side. So then the universe exists in topology X, and that is the first condition. Next, if A1 and A2 exist in topology X, then A1 intersection A2 exists in topology X as well. So we'll start off by assuming that. So since A1 exists in topology X, then A1 is a subset of X. And what gave us that A1? Well, there must be a B in topology Y such that A1 is equal to the inverse image of that B1. So this B1 will give us the A1, and that's how A1 exists in topology X. And we need a second A, so we will pretty much rewrite the same. That way we can have two open sets in topology X and show that their intersection exists in tau X as well. Inverse image of B2. So